Question here, and the question reads: An industrial raw material has the following composition by mass: iron, they say is 28.1%, chlorine 35.7%, and also water of crystallization X%. We are asked to find the value of X, and also we are asked to find the formula of that compound, that particular raw material. Now, very easy. First of all, let's find the value of X. We are given three entities there. First of all, we are told that iron, this is formula for iron, Fe. Iron contains percentage by mass of 28.1%, and chlorine, Cl, contains 35.7%. A water of crystallization. Water of crystallization is not an element. It is the water that is being attached with a particular compound, mostly salt, that can be able to crystallize, and it is written H2O, right? So this is the water of crystallization written as H2O. Is equal to X. We don't know the value. And first of all, we are asked to find the value of that X. And secondly, the overall formula for that particular raw material. Now let's solve for X. Now all the information given to us here is in percentage, and we know percentage is all over 100, right? So how do we get the value of X? The value of X is simply 100, which is the total percentage, equal to minus whatever the sum of iron and chlorine gives us. You subtract that by 100, and then you get the value for the water of crystallization. Very easy. And now let's solve for that. 100, and if you sum all this, if you sum 28.1 plus 35.7, that gives us 63.8, and when you subtract 100 from that, it simply gives us 36.2. So this is the value by percentage of the water of crystallization. So we got to our first answer. Our first answer percentage is 36.2 water of crystallization. Now the second step, we're asked to calculate for the formula of that raw material. Now this is very easy. First of all, the first step, we have to write out all the elements or all the entities present in that particular compound. We are told that it contains iron, chlorine, and water of crystallization. Secondly, we have to calculate for the number of mole. Number of mole of a particular atom or an element is simply the mass all over the molar mass. But in this case, we are not giving the question in terms of mass. We are giving the equation in terms of percentage, right? So it is simply the same thing: percentage divided by the mass number, which is the percentage divided by the mass number to get the number of mole, or mass all over the mass number. Now, what is the percentage of iron here? 28.1, chlorine 35.7, and the water of crystallization, we calculated it to be 36.2. Now, we are in that question, we are also given the mass numbers of all the elements, right? We are told that iron, in that question, iron is 56, so divide by 56. Chlorine, we are told that it is 35.5, and water, hydrogen is 1, oxygen is 16. So 16 plus 1 times 2, because hydrogen is appearing twice here, that simply gives us 18. Right, so how do you calculate the number of mole? Percentage all over the mass number, or mass of that particular element divided by the mass number. So we are giving it in percentage, so we are going to solve for that of percentage. Now, very easy. 28.1 divided by 56, and that gives us 0.1. So this is the number of mole of the iron present. What about for chlorine? 35.7 divided by 35.5, that gives us approximately 1, right? 1.005 or any other value, but approximately 1. What about 36.2 divided by 18? That simply gives us 2, right? Approximately 2. So all these are the number of moles, right? These are the moles. Now, the second step, this number of moles, in order for us to get the accurate atoms present in that compound, we have to divide the number of mole by the smallest. Now, if you look at all these numbers, which of them do you think is the smallest? 0.5, 1, and 2. Definitely it is 0.5. So divide iron by 0.5. Also divide this by 0.5 and divide water of crystallization by 0.5. So 0.5 divided by 1, 0.5 divided by 0.5 gives us 1. 0.5 divided by 1 divided by 0.5 gives us 2, right? And 2 divided by 0.5 gives us 4. So all these are the values, the atoms present in that particular compound. So have one, iron here has one atom, right? Chlorine has 2 atoms present. And water of crystallization is written like this. This is the water attached, right? To have 4 water of crystallization. This is how water of crystallization is written, right? It is not written in this format, right? Because it's an attachment to a particular compound. So in summary, we have iron, Cl2, and 4 water of crystallization. So this is the formula for that particular raw material. Have a nice day and bye for now.